Hello learners, welcome to this course on Embedded System Design using PIC16F877 Microcontroller. In this tutorial, I will be discussing about on how to interface a electromagnetic relay with PIC16F877 microcontroller. So a relay is a electrically controllable switch. Whenever we have appliances working with higher voltages, higher current ratings, if I want to control those appliances using a microcontroller, then we can make use of this electromagnetic relay. So the electrical signal provided by the microcontroller will be used for activating a coil, so thereby a magnetic field will be induced, so due to which the external supply voltage can be routed to the appliances. So thereby the controlling of the appliances can be done using a microcontroller. So it is mostly used in industrial controls, automobiles and in appliances. So this electromagnetic relay is of 4 different types: SPST, single pole single throw; SPDT, single pole double throw; DPST, double pole single throw; and DPDT, double pole double throw. So this is the symbolic representation of these 4 types: SPST, SPDT, DPST and DPDT. In SPST, single pole single throw, we have a coil. So this coil can be excited with the help of a microcontroller, thereby a magnetic field can be induced. When this magnetic field is induced, it can attract the lead connected to A, so thereby the A terminal will get connected to B. So we can connect the supply voltage to terminal A and we can connect the appliances to terminal B. So thereby whenever the coil is excited, the magnetic field will make the lead to become short circuit, thereby the external supply voltage can go to your appliances for powering it up. So here the control of one device is possible. So that is why it is called a single pole, and single throw in the sense it has one option, either open circuit or short circuit. The second type of relay is your SPDT, single pole double throw. So here also the coil excitation principle is same, whereas once the coil is excited, the lead can be in any of this type. So for example, when the coil is not excited, the terminal A is disconnected from terminal C. So the terminal A is called as normally open terminal. And the terminal B is by default short circuit with terminal C. So terminal B is called as normally closed terminal. So upon excitation of the coil, now C gets connected to A. So what we can do is we can connect a supply to terminal C and we can connect the appliances to terminal A. Whenever the coil is excited, the supply from terminal C will pass on to the appliance connected to terminal A. Thereby it can get powered on. So here also control of one device is possible. So it is called a single pole and the switch has 2 options, normally open and normally closed option. Next type is DPST. So here it is double pole single throw. Double pole means now controlling of 2 devices can happen simultaneously by exciting the coil. So by exciting the coil, the appliances connected to B1 and B2 can be switched on or off simultaneously. And the supply given to A1 and A2 can be diverted to this B1 and B2 simultaneously is possible. So this is double pole single throw relay. And the last one is double pole double throw. So here also we can connect 2 devices and these 2 devices can be controlled simultaneously. So we can connect the power supply in C1 and C2 and we can connect the appliances to A1 and A2. So whenever the coil is excited, the switch C1 will get connected to A1, C2 will get connected to A2, thereby power on your devices connected to A1 and A2. So these are the 4 types of relays. Now in this project, we are going to use a Micro C Pro for PIC for writing our embedded C program, and we are going to build the circuit using Proteus 8 Professional. So we are going to write an embedded C program, convert it into an hexadecimal file. Then that hexadecimal file will be ported to your microcontroller in the Proteus 8 professional software. So what we are going to do is, we are going to make use of a PIC16F877 microcontroller. A switch is going to be connected to RC0. Depending upon the status of the switch, we are going to switch on the relay. So a relay is connected with a supply and the appliances working with higher voltage or higher current rating. So for this example, I am going to take a 12 volt bulb connected to the relay. So whenever the switch is activated, a logic low signal will be generated here in RD0. Thereby the relay will get excited and the power supply 12 volt will get diverted to your bulb. Thereby the bulb glows. So now let us start with the project. First let us open Proteus environment, create a new project, select a location for your project, select a location for your project, select a name for the project, press next, select a default schematic. We are not going to use a PCB layout and I am not going to use a firmware. So leave it as it is, press next. So only schematic is selected, press finish. So this is the schematic where we are going to build the circuit. So in this, first we need to select the components. So select the components using PIC devices, 16F877 microcontroller. Double click on it, it will get added to your list. Then I require a electromagnetic relay. So relay, so I am going to make use of relay, add it to your list. Then I require a crystal, select it, add it to the list. Capacitors, add it to the list. Switch for reset circuit, add it to the list. Resistor, add it to the list, and I am also require a lamp. So a lamp, I try to take an animated light bulb. Double click and get it onto the list. So after selecting the components, I can close this window. So now use these components to build the circuit. So first let me select the microcontroller, place it onto our schematic, take the crystal, I am going to rotate it and place it onto our circuit. Connect it to pin number 13 and pin number 14, oscillator pins. I am going to take the capacitor and place it onto the circuit for producing stable oscillator frequencies. So it is getting connected to the crystal. And I selected ground terminal to connect the capacitor values. So I select a crystal, right click on the component, edit properties. I am going to use a 10 megahertz crystal. So type 10 megahertz, press OK. Same way the value of the capacitor, it can be 33 picofarad or 22 picofarad. So I am going to use a 33 picofarad capacitor. So this completes our oscillator circuit. Next we are going to build the reset circuit. For selecting the components again, go to components mode, select a switch, I am going to rotate it, place it onto the circuit, then a resistor, place it onto the circuit, connect one end of the resistor with the switch, and other end I am going to connect a ground to the switch and power to the supply resistor. Then the memory clear pin, I want to connect it to the intermediate point. So when by default this pin will be at logic 5. Whenever I close the switch, this pin will go to logic low, which means the reset operation will be carried out. So this completes the reset circuit. So now let us go and build the relay part. Again go to components mode. So here in our program we are going to use a switch connected to RC0 and a relay connected to RD0. So I am going to take a relay, place it onto the circuit. So RD0 I connect it to one end of the coil, another end I am going to connect it to power supply. Then we need to connect a lamp. Go to components mode, select a lamp, I'll rotate the lamp, place it onto the circuit, connect a 12 volt lamp to normally open terminal, and the other end of the lamp I am going to connect it to ground. And we need to provide a 12 volt supply for energizing the lamp. I go to generator mode, I select a DC supply, place it onto the circuit, connect this DC supply here. Then we need to select the value for this relay. So right click on the supply, edit properties. So here I give 12 volt DC supply. And right now the coil is a 12 volt coil, but it should be operated by a microcontroller which suppose 5 volt. So I want to change this relay, 12 volt relay, to a 5 volt relay. For that, right click on the relay, edit properties. So here component value I need to change it to 5 volt. Then only the coil will get energized. So I modify the coil excitation voltage to be 5 volt. Okay. Now you can see it is changed to 5 volt. So now we need to connect a switch. Again go to components mode, select a switch, place it onto the circuit. I am going to use a resistor, rotate it, place it onto the circuit, connect this end to one end of the switch, and RC0 is connected to the switch, and other end of the switch I am going to connect it to the supply. So by default, so the resistor other end I need to ground it. I connect a ground to this resistor. So by default this RC0 pin will be at logic 0. Whenever I close the switch, the power supply will pass on here and it will get 5 volt at the RC0. So whenever I get a logic high in RC0, we try to produce a logic 0 to the coil, thereby the coil will get excited, then the power supply will be routed to the lamp for powering. So with this we complete the circuit. Let us go and build the embedded C program. So save the project. Now let me open micro C, create new project, a standard project, select a location for your project. So in micro C I am going to put the project. Okay. Give a name for the project, relay. Select the IC, microcontroller IC, for which you are going to do the programming part, and select the device clock. So device clock I am going to put it as 10 MHz. So here we are doing 4 things. One is selecting a location for your project, giving a name for the project, selecting the microcontroller for which we are working on, and selecting the device clock frequency. Press next. We don't have any files, so I leave it as it is, finish. So here you can see a project has been created with the name relay, and you can also see the source file, relay.c. So here we can write the program. So first thing is I need to initialize the port C to be an input pin and port D to be an output pin. So we can save the project, relay.c. So first thing is I give tris C dot F0, I am going to set it to 1, which means I am configuring port C 0th pin to be an input pin. Same way, tris D dot F0, I need to set it to 0 because we have connected a relay there. So we need to configure the ports D 0th pin to be an output pin. So then we can start with a while loop, while of 1. Open close parenthesis. So first I need to check the status of the switch. For checking the status, if port C dot F0 is equal to 1. I am checking whether port C 0th pin, whether it is logic 1. So logic 1, when it will happen? Whenever the switch is pressed, it will come to logic 1. So if that is the case, I need to activate the relay coil. So activation of the relay coil will be done by port D dot F0 equal to 0. So 0 will activate the coil. So I want to retain this output for some time. So we can put a delay underscore ms for 1 second, 1000 millisecond. And in the else part, if the switch is not pressed, in that case, I need to deactivate the coil. So that is done by port D dot F0 equal to 1, come out. So this is what we do here. So when we check the switch, when the switch is activated, then we activate the coil. So thereby the power supply will be diverted to the appliance and appliances will start working. If the switch is not activated, then automatically what happens? The coil will get de-excited, thereby it will not get switched on. So let us build the circuit. So there are no errors. So let us go and put this hexadecimal file into the microcontroller. So right click on the component, edit properties, select the program file, hexadecimal file. Micro C relay, and I have set it as 10 megahertz. Processor clock frequency is set to 10 megahertz. Press OK. So we have put the hexadecimal file onto the microcontroller and also we have set the clock frequency. So now let us see the output by pressing this play button. Right. So now RD0 is at logic 1. So the coil is not excited. So power supply is not routed to the power supply. So when I close the switch, what happens? You can see the light starts glowing. So now RD0 becomes 0. So thereby the coil gets excited. So now you can see the lead. The power supply is connected to the normally open terminal and the power supply goes and excites the 12 volt bulb. So if I release the switch, you can see automatically it goes back to the normally closed terminal and the lamp goes to off state. So if I press it again you can see the light bulb gets activated. So like this we can interface a high powered devices to our microcontroller and start controlling them. So in this tutorial I have discussed about on how to interface an electromagnetic relay with the PIC16F877 microcontroller. Thereby we can control the high powered devices. Thanks for watching. Please subscribe for more technical learning. Thank you.